Hello, this is Vlad Stoyanovsky, and today we will apply the power of Watson Analytics to answer common questions and concerns in higher education. We will examine things that are usually top of mind, such as how to retain students until they get their degree. The more time they spend here, the more they contribute financially to the health of our institution. Also, the quality of students we admit and their graduation rate impacts our national and regional rankings. But we don't just want to get a picture of what is going on. Rather, we want to understand what drives students to graduate and how we should change our processes and investments to make the right impact. So those are some of the things in our mind as we start exploring our data. Because Watson Analytics is available in the cloud, all I need to begin is a browser. This is the dataset that we will be using today. There are several dozen columns that contain a variety of information per student. So demographic information, academic information, admission information, and how they're performing at the university after they have been admitted. Prior major, current major, whether they have graduated, etc., etc. All I have to do to get started is to either drag and drop this spreadsheet into Watson Analytics or browse to it and upload it to Watson Analytics. So Watson Analytics will upload this data. It will structure it, index it, and even analyze it, as you will see. It will look at relevancies between various data points and suggest some paths of analysis for us. As you will see, Watson Analytics is not just about pretty pictures and visualizations, although it certainly has them, but it really is about getting fast and clear answers to questions. So with that, we can begin our exploration. As I start my exploration, I can start by typing a plain English language question in this box. But you will also notice that Watson Analytics is proposing some questions that we might want to be asking. Here's one example that is of interest. What are the values of academic index by state? Academic index is a score that our admissions department assigns to every incoming student. And we believe this to be very important in determining how well students will do and whether they will graduate at our institution. So the quality of our students is something that's very important to us, and Watson Analytics proposes to show us the geographic distribution of academic index. So let's go ahead and click on this. And Watson Analytics gives us the answer to the question in the middle of the screen. So here's the question: what are the values of academic index by state? And before us is the answer. So as we hover over each state, we can find what the answer is on a per state basis. Quickly we can see that Wyoming has the highest, or one of the highest, academic indices in the nation. Before we continue, I'd like to explain some of the other things that we're seeing on the screen. Below the visualization, we have a couple of options. We can pin any of these visualizations as we interact with them as a favorite, so that we can quickly return to them. Also, just because Watson Analytics believes this to be the most appropriate visualization, we don't have to agree. We can choose to see the answer to this question in a number of other different visualizations. And there's also different options per visualization that we can choose. Below the visualization is the source data. So as we interact and explore, this is the backup information or the background data behind what we're seeing on the screen. This is what our source data looks like. Watson Analytics has a very powerful data audit capability, and this capability allows us to quickly understand what the data looks like and how it's distributed. You will also notice a quality score on a per column basis. Let's take a look at a couple of these to understand what this means. For example, gender has a relatively high quality score of 93. That's due to a couple of reasons. First, there are no missing values. Secondarily, the values of male and female are pretty evenly distributed in the data. So Watson Analytics not only believes that this column is of high quality, but that it is also very relevant to the questions that we ask. In other words, if it was tilted significantly in one direction, such as some of these other columns here, then the value of this column for analysis may be diminished, simply because the data is so skewed towards one direction. Here's academic index, and that's the variable that we were looking at on the main screen here, the values of academic index by state, you will notice that there is a bell curve distribution of the data in the data set. And the highlighted column shows where more of the values fall into. And also at the top of the screen, we have additional insights. The question that we asked was, what are the values of academic index by state? Based on this question, Watson Analytics is suggesting additional insights that we can use to continue our analysis. So we can take multiple directions in our analysis here. For example, here I see admission age by academic index. Our 14-year-olds on average have the highest academic index, followed by 27-year-olds and 24-year-olds. That's not the question that we asked, but it's related, and Watson Analytics believe that it's relevant to the line of thinking that we have in mind. Academic index by applicant type. So hard copy applicants have by far the highest academic index of any other applicant type. In fact, there seems to be much less variation between web applicants and the lowest applicants to the university. And there's some additional insights here as well that we can follow. Now let's focus on the question that we asked and the answer. Here's the question, and it's answered on a by-state basis. So quickly we find that Wyoming has the highest academic index, and we can confirm that with the scale on the right. So 8.5 is the highest, and that's the score of Wyoming. And we can see that some of these other states have a lower academic score. Now by clicking on this legend, I can actually focus on the states with high or low scores. So if I slightly slide it to the right, you will notice how Watson Analytics points out the highest performing states by academic index on average for incoming students. And if I scroll it to the left, I get the opposite effect. Now, as we look at this visualization, we may have additional questions. For example, the state of Texas. It's in the middle of the road. It's not very low, it's not very high. If we're interested in this particular state, we might want to take our analysis in a number of different paths. So from here, we can drill through to anywhere else in the data. For example, I may want to understand how private schools versus public schools are doing in terms of academic index for this particular state. So here, I will right-click, and I will drill through to any of the other data points. And here's high school type. So now we can look at the academic index for the state of Texas by high school type. And again, Watson Analytics creates a visualization that did not exist before. No power user had to create this visualization for me. And what I find here is obviously the answer to my question, and that is that there's very little variation between the different types of schools. Private is at 7.2, public slightly lower at 7.16. And there's a category of other as well, which is the same as public. At any point, we can undo and go back in our analysis. As we saw earlier, we can focus on the top 5 or top 10 states by using the slider or the bottom states. But what if I want simply a list of the bottom 5? Rather than using the slider, I can just ask that question in plain English. So let's ask our first plain English language question, and that is, what are the bottom 5 states by academic index? And you will notice that Watson Analytics help us auto-complete the question. And we'll pick the top question here. And here are the bottom states by academic index in ascending order. So Michigan is at the bottom, and Connecticut is the 5th lowest for academic index. Now you will notice that we also have blanks in the data. And I may not care to see blanks. So if I want to exclude this from my analysis, all I have to do is right-click and exclude that value, and now we will see that the 5th lowest is the category of international. So now I'm starting to get a feeling for the geographic distribution of our academic index. But the outcome that I'm really interested in today is graduation rate. I'd like to understand what are our graduation rates by school, by major, and by other factors. So let's ask a different question. We'll ask Watson Analytics to give us the student count by school and graduation rate. And we'll ask exactly that question. So we'll say, give me the student count by school, and graduation rate. And again, Watson Analytics help us autocomplete. And this is the answer to our question. So we have the student counts by whether they graduated or not graduated, and by school. So we can distinguish the green from the blue very easily here. School of Humanities, we can see the count for how many graduated, how many did not graduate. One thing that's obvious, however, is that School of Humanities, School of Business, School of Art are much bigger than School of Education, for instance. So it's a little bit hard to compare these schools, apples to apples, if you will. So what I'll do is I'll slightly change how this chart is shown. I can change it and show it as a stack chart, or I can also show it as a stack percent chart. So now we can more easily compare these schools on an equal basis. And here we find that the School of Science actually has a pretty large amount of students that are not graduating. Now this is something that would ordinarily concern me, because while I expect some of the other schools to have a high degree of students not graduating, I would think that the School of Science has a lesser number of students not graduating. But I also know that the School of Science has a large number of pre-majors. So what I might want to do is exclude pre-majors, because pre-majors do not graduate as such. So as I scroll in the data here, I find the column for pre-major. I will click on it and ask Watson to show me only those that are not pre-major. And the visualization updated to show only those students that are not pre-majors. You will notice here that we are showing students that are not pre-majors only, and you can also see a visual clue here as to how much of the data is actually shown. So roughly half of the data is shown, which means that half of the data are pre-majors. While this looks better, I'm still concerned about the School of Science. So I'm going to want to dig deeper and understand which majors are actually not performing so well for this particular metric of graduation rates. I simply double click on Science, and that will drill down into the majors for that school. Watson Analytics is smart enough to create hierarchies in many cases. In cases such as geography and a time dimension, geographies are pretty easy to figure out. So if you have a date field, Watson Analytics will automatically calculate years, months, days, etc. Same holds true for geography, but also based on the distribution of the data, Watson Analytics is often able to automatically figure out other hierarchies as well. And as a user, I can also define my own hierarchies. I can also define my own data groupings and calculations between columns. So here we're seeing graduation rates by major, and we find that dual engineering majors have a 100% completion rate, whereas computer science and environmental engineering have the lowest within this particular school. So this is one way to look at graduation rates, by school, by major, but really we have dozens of columns, as you saw. So I can look at graduation rates by any of these variables. For instance, I believe that Greek affiliation, and in general how involved a student is on campus, to have a significant impact on graduation rates. The more a student is involved on campus, the more likely they're to remain longer, and thus they're more likely to graduate. Let's see if that holds true. We'll slightly modify the question and ask for graduation rates by Greek affiliation. And my suspicions are correct. So students that belong to a sorority or a fraternity have a pretty high graduation rate. Those that do not have a lower graduation rate, and those that were rushed but did not make it into a fraternity or a sorority have the lowest rate of graduation. Let's take a look at a few other variables. First generation. Do first generation students that are first in their families to attend college have a higher chance of graduating? And at our university, that is certainly true. First generation students have a higher graduation rate. What about whether students live on campus or are commuters? I would think students that live on campus are more involved and more likely to graduate. The data, however, tells a different story. Commuters actually have a higher proportion of students graduating than those that live on campus. So I find this interesting, and I might want to pin this down for further analysis. What about programs that we invest in? Programs such as campus retreats, campus visits, student orientation. These are things that we invest in. Could they potentially have an impact on whether students graduate or not? Let's take a look. So here we have campus retreats, we also have orientation, we also have student visits in this data set. Let's take a look at campus retreats first. And what we find here is counterintuitive. So students that did not attend campus retreats have a higher ratio of students graduating versus those that did attend campus retreats. Another interesting finding, I will go ahead and pin this one as well. As you can see, we can keep analyzing graduation rate by any of these variables that we have. Let's take one more, athletics. What we find here is that students that are current athletes have lower graduation rates than non-athletes as well as prior athletes. A more sophisticated analyst, however, will want to look at more than just one variable and see how that impacts graduation rates. For example, we looked at academic index in the past. I may wonder whether academic index in conjunction with discipline infractions lead to higher graduation rates. And what about admission age? And how does that look by cohort? So if I want to add additional variables, I may ask a slightly more complex question. Something like, does higher academic index and lower discipline infractions lead to higher graduation rates? I will go ahead and ask that exact question. And because we're asking a question that has a couple of variables, a bubble chart or a scatter plot is the most appropriate way to visualize the answer. And what we find here, that students that do not graduate, which is the green color, tend to have more discipline infractions and a lower academic index than those that graduate on average. Now we said we wanted to expand the question by adding a couple of different variables, such as cohorts. Let's go ahead and add cohorts into the chart. And what we find is that consistently those students that graduate, on average, regardless of the cohort, have one or less discipline infractions, so regardless of the cohort. Whereas those that do not graduate typically have more than one discipline infraction, with the exception of this particular cohort. What about admission age? Let's take a look at how admission age fits into this picture. And now the size of the bubble is the age of the student. The larger the bubble, the older the student. What we find here is that older students tend to have a lower academic index, higher number of discipline infraction, and are less likely to graduate. So I find this chart to be quite informative. Let's recap what we've learned thus far. In just a few short minutes, we found that academic index, discipline, Greek affiliation, and more variables impact graduation rates. But which of these is more important than others, and how do they interact with one another? You can see how that, as an analyst, I can come up with many ways to improve graduation rates. But which one will be really effective? Moreover, they'll have different costs associated with them. For instance, investing in financial aid has a different cost than investing in improving the levels of student involvement on campus. So how do I know I'm making the right investment for a student or a group of students? This is where the power of Watson Analytics Predictive Analytics comes in. I can ask Watson Analytics to tell us the best predictors of graduation rates. We will create a new prediction that will tell us the drivers of graduation rates. By default, Watson Analytics will find some things that it believes are interesting to predict. So here it's found total semesters, graduation rates, discipline infraction, and athletics. We want to focus on graduation rates for simplicity, so we'll go ahead and eliminate these other targets. And we'll call this higher ed prediction. Watson Analytics will now analyze thousands of data points. A person can't do this by visualizing and exploring the data. Watson Analytics will take a look at every single data point and each attribute and give us the answer on what is driving graduation. The first thing we see on the screen is a bullseye chart. In the middle of the bullseye is the variable that we're trying to predict, which is graduation rate. The points around it are the key drivers of graduation rate. So total number of semesters, disciplinary fractions, and other points. The drivers are described in plain English sentences. And if we click on View All, we will see all of the important drivers of graduation rate. So out of the several dozen columns, Watson Analytics has identified about a dozen that strongly influence graduation rates. So while some seem obvious, such as total number of semesters that a student spends at the university, something like how far ahead a student has applied may not. Let's take a look at this driver. It seems to be a really important driver. In fact, Watson Analytics gives it a predictive strength of 75%, which means that Watson Analytics is going to be correct 75% of the time in predicting whether a student will graduate based on how far ahead that student has applied. There's a couple of different ways to visualize this. And in this visualization, we find that students that applied 43 weeks in advance or further out have the highest rate of graduation, 81% in fact. And those that applied 32 weeks or less ahead had a 67% graduation rate. You will notice that Watson Analytics has performed a binning here. Each student has a single value, so a student might have applied 32 weeks in advance, or 36, or 50, or 45, or whatever the value may be. Watson Analytics has applied a binning here for us to more easily digest this answer. And these statistical details give us further information as to how such binning was performed. And if I click on this, it's going to go to the documentation and explain what equal frequency binning means. And additional statistical details can be found by each statistical statement here. Orientation. This is an activity that we also invest in. We like all of our students to go through orientation, or as many as possible, and we like to think that this helps us admit students that are likely to graduate. Let's take a look at the correlation between orientation and graduation rate. And what we find here is that those students that do not attend orientation have a higher graduation rate, 78%. Versus 70% for those that do attend orientation. So this is another interesting finding that I may want to investigate further. Lead source. This is something that our admissions department has an interest in. Some lead sources are better at attracting students that are more likely to graduate. Let's take a look at this. What we find here is that students that are attracted through these lead sources have a 100% rate of graduation. Whereas students that are attracted through these lead sources, and you can see how they have been binned here, so art, school inquiry, college view, etc., these students have a 64% rate of graduation, which is the lowest on this chart. And again, binning was performed here by Watson Analytics. We can find out the type of binning here, and it's a supervised merge, which is different from the binning that was performed in the previous example. So again, statistical details are available behind every finding here. So we've looked at a few single drivers to graduation rates, but typically 2 or more drivers in combination have a higher predictive rate. So if we switch to 2 field drivers, we find that the combination of total semesters and disciplinary fractions together are a better predictor of graduation rates than each one of these on their own. In fact, if Watson Analytics knows the values of these 2 variables, it's able to predict with 93% certainty whether a student will graduate or not. Similarly, the combination of total semesters and orientation have almost a 93% predictive strength as well. Let's take a look at this particular finding. Again, I find this interesting because students that did not attend orientation and spent 6 to 8 semesters at our university had a 97% graduation rate, whereas those that spent the same amount of semesters at the university had only a 90% graduation rate. So clearly the kinds of students that we're attracting that go through our orientation are less likely to graduate than those that are not. And finally, a combination of 2 or more factors is an even better predictor of why something happens. So in our case, these factors taken together have a higher predictive strength than the previous variables that we looked at. Decision trees are a great way to visualize how multiple variables influence an outcome. Let's take a look at this decision tree. And decision trees also give us the business rules behind why certain things happen. So here we can see that of all the records, 75% of all students graduate, 25% do not. However, of those students that spend 6 to 8 semesters, 95% graduate, and you can see that that's most of our students, 68% in fact. And you can see that also by the thickness of the line that leads into this box. Of these students, those that have 1 or less discipline infractions have a 96% rate of graduation. And again, this is most of our students, 67%. And of these students, those that did not attend orientation have a 99% rate of graduation. So you can see how I can follow this and find the best rules that determine whether a student graduates or not. Similarly, I can find the rules for when students do not graduate. Another way to view this is by looking at the decision rules themselves. This is a very clear and concise way to understand when students graduate. So students that follow these rules have a 100% rate of graduation. Students that follow these rules have the lowest level of graduation. Another way to look at this is students have the highest percentage of non-graduates. So if students follow these rules, then 98% of them will not graduate. Now I can take these rules and apply them to our admissions process. And this is where I can start to have a real impact on improving our graduation rate. Now we also found that total semesters is the single most significant driver of whether students graduate or not. So another way to look at this problem may be to understand what is driving our students to stay longer on our campus, to spend more semesters with the university. So for that, I can replace what's in the middle of this bullseye. I will simply drag total semesters into the middle of the bullseye. And now what Watson Analytics gives me is the top influencers of total semesters. And what I find here is that Greek affiliation is a very significant influencer of how long students spend on campus. This is clearly an area that, if I make the right investments in, would lead to my students spending more time on campus and thus be much more likely to graduate. In addition to being able to tell us what is driving certain outcomes, Watson Analytics also gives us top field association. So regardless of what we're trying to predict, Watson Analytics will give us other interesting points in the data. Let's take a look at a couple of examples. So academic index and high school GPA are positively correlated. And this chart gives us that correlation. We can see that we could probably draw a trend line right here. And as a matter of fact, we'll go ahead and show a trend line here. So that's the trend line. And the good news here is that the darker points have a higher number of records and they seem to be scattered at the upper right quadrant of our chart. So most of our students have a high academic index and have a high school GPA. We can see that there is a strong correlation here. It's a strong positive correlation, and by clicking on these underlined terms, Watson Analytics can explain what they mean. We can also get the statistical details behind every one of these findings, or view the details behind the correlation. So it's a pretty strong positive correlation, meaning that as one goes up, the other one tends to go up as well by this factor. Let's take a look at one more interesting finding. Current school and prior school are strongly associated. What I have here is the prior schools on this axis and the current schools on this axis. So here we can see how students change schools as they change their majors. In fact, in most instances, students did not change schools when they changed majors. So the biggest bubbles here are business to business and humanities to humanities. The biggest exceptions that I see are business to humanities, which happen 10% of the time. So 10% of the time when students changed their major, they went from the business school to the humanities school. Whereas only 6% went in the opposite direction. So they switched from the School of Humanities to the School of Business. So another interesting finding that was presented to me without me having asked for it. And again, we can look at the details of the correlation. So a pretty strong correlation, and it's visualized on this chart. Now that we have seen the explore and predict power of Watson Analytics, let's take a look at one more capability, and that is the ability for a business user to assemble their own dashboard. There are a number of templates that I can use. I will start with a free form. Now remember that we pinned interesting findings. I can take those findings and I can simply drag and drop them into my dashboard, or I can start from scratch. So I may want to get a map of students by admission age, for instance. So I'll just type admission by state. And as simple as that, we get our visualization. Again, nobody had to create this visualization. I just typed what I wanted to see. Perhaps we also want to look at students by gender. I'll drag and drop gender here from our columns. And student count. And there's our chart. Now, if I don't like this chart, I can pick from many different visualization options. I think I like this one better, so we'll just use this chart. I may also be interested in discipline infractions. We'll just drag and drop this measure. And finally, we'd like to filter our dashboard, and we'll do it by cohort term. I can also change the style to something that's more to my liking. And now all of these objects are automatically linked. So as I click on females here, everything filters for females. So total number of discipline infractions for females, average age by state for females. If I click on males, you will notice how everything changes for males. Also, as I click on a state, you will notice that the other objects update as well. And furthermore, I can filter on a cohort. So I can look at 2004, compare that to 2010. And now we have a dashboard that we can save and share with other users. So over the last 30 or 40 minutes, we were able to take a data set, get answers to all of our questions by exploring it, find the drivers, the key drivers of our most important outcome, and that is graduation rate, and then visualize and share those findings with others. In fact, in working with one of our higher education customers, we found that the predictive findings that Watson Analytics was able to give us in a matter of minutes were very similar to the findings that it took them several months to generate using traditional statistical methods. So that is the power of cognitive computing. That is the power of Watson Analytics. And with that, thank you for watching.